Today's video lesson. In this lesson class, we are going to be looking at likely post-UTME word question. Now let us look at the question on the board to begin with. The first question for today's video lesson reads this way. A mass of 0.5 kilogram is attached to one end of a helical spring and produce extension of 2.5 centimeter, okay, with an amplitude of 10 millimeter. The period of oscillation is what? In this question, we are told to calculate for the period of the oscillation of the what? Of the spiral spring, okay? Now let us solve this question. The mass given to us, mass is 0.5 kilogram, okay, is attached to one end of a helical spring and produce extension. The extension is 2.5 centimeter. Okay, as usual, we have to convert from centimeter to meter by dividing the value with what? 100. And that will give us 0.025 what? Meter. Wow. Okay, with an amplitude, your amplitude for this question is 10 millimeter. So we have to divide by 1000 to convert to meter. So you have 0.01 meter. So we have to convert millimeter to meter as well as centimeter to meter. So we have done that, okay? Now, the period, we are looking for word period of the word oscillation. Then gravity is 10 meters per second square. Don't forget that the period of simple pendulum is given as period equals to 2 pi square root of L over G. This one is the period of a word of a simple pendulum. You must know that. This is for a simple pendulum. And for simple pendulum, the period do not depend on the mass of the object. So for simple pendulum, we do not need the mass. But for helical spring, such as the springs that looks like this, you need the mass, okay? The period of an helical spring is equals to 2 pi square root of n over k. Your k here signifies your elastic or your force weighting constant. Yeah, that what it signifies. So it can be gotten from your what? Your Hooke's law. It can be gotten from your Hooke's law. So you must understand the period of a helical spring. This one is for a helical spring, okay? This one is for simple pendulum. This one has to do with trend. You understand? But this one has to do with a helical spring. That means a spring that has what? Extension. So you must understand the context of these two periods. But as for this question, it is not simple pendulum. It is your word, your helical spring. So because of that, we are going to adopt formula what? Formula 2. Okay, let's quickly adopt formula 2 and see what the answer is going to be. According to formula 2, period is equals to 2 pi square root of n over k. Now, getting the period of this pendulum is not difficult at all. But the only problem is your force constant. We do not know our force constant. So what do we have to do? Our force constant, remember from Hooke's law, is equals to Ke. So you can get your force constant from F equals to Ke. More also, remember that your force can be what? Mg equals to weighting Ke. So K will give us Mg over what? Over E. So K will give us mass is 0.5. Remember, gravity is what? 10. Extension, what's our extension? 0.025. So let's quickly do this to get our force weighting constant. So our force constant will give us 0.5 times 10 divided by 0.025. 0.5 times 10 divided by 0.5 times 10 divided by this will give us 200 Newton per meter. This is our force constant. Wow, that's interesting. So we are going to get the period. Period is equals to 2 pi. Our pi is 3.14. Don't forget, that's 22/7. times the square root of m. What's the mass? The mass is 0.5 all over your constant, which is what? 200. So if I multiply this by this, I will have 6.28 times the square root of 0.5 over 200. So you have 0.5 divided by 200. You have 2.5 times 10 raised to the power of minus 3. So that's what we have. So what do we have to do? We'll get the square root of this, then we'll multiply with this. So let's get the square root of 2.5 times 10 to the power of minus 3. Is it possible? Yeah. You have square root 8 times 0.05. So let's quickly multiply 6.2 times 0.05 times 6.28. That will give us 0.314 waiting seconds. So the answer to this question is 0.314. Let's check the question. The answer is what? A. So let's take question number 2. Now let's take question number 2. According to question number 2, he said the color seen in rainbow is due to what? What is the color seen in rainbow? Rainbow is caused by what? Don't forget that rainbow is due to the dispersion of white light by a prism droplet of water. What do I mean? Let me explain. Remember that if water drops like a prism, like this. This is what we call the drop of water. It must be noted. Now, what shape is this actually? This looks like a prism. Now, when light from the sun falls on this drop of water, this is light from the sun called white light. It must be noted. Now, what usually happens is that refraction will take place. This ray is called the refracted ray. And when that is done, because the white light is a combination of 7 colors, the colors will be separated. Why? Because these colors of light do not have the same speed in water, even also in glass. What do I mean? I'm trying to say that the colors of white light combines together in air. But as soon as they get into another medium, such as water and glass, the colors will be what? Separated. And this is what is going to happen. You're going to get red, orange, yellow, blue, green, indigo, and what? Violet. These are the 7 colors of rainbow. Now, this phenomenon is due to waiting, is due to dispersion of white light. Yes, dispersion means the separation of white light into components of words, colors. So they said that the colors seen in rainbow is due to what? It is due to waiting dispersion. So the answer is word A. Now, where do we have refraction? Dispersion is caused by refraction, okay? Yeah, dispersion is caused by refraction. So if the question had said that the separation of white light into a component of colors is due to what? It is due to refraction. But they said that the colors that you see is called what? Is due to what? Is due to the dispersion of white light by a prism droplet of water. So the answer to this question is word A. Now, question number 3. He said the human eyes are more sensitive to which color? Is it all the colors? Is it red color? Is it green color? Is it blue color? The answer is word the green color. Don't forget, in rainbow, the green is at the middle of the colors of royal beef. Don't forget that. This green is the most sensitive to human eye. Most sensitive light. Sensitive color of light. The green light is the most sensitive color of light. It must be noted. Green color. Now, the fourth question says, Planck constant has the same dimension as words. Now, how do we know the dimension for Planck constant so that we can compare with the dimensions of these other word options? All we have to do is simple. Let's get the dimension for Planck constant and try to get the dimension for angular momentum to see if they are the same. Let's do that quickly. take question number 5. According to question number 4. According to this question, which of these has the same dimension as what? Planck constant. Wow. A, power. B, momentum. C, energy. D, viscosity. How do we know the dimension for Planck constant? First of all, you must understand that your Planck constant is gotten from a theory called quantum theory of light. Yes, the symbol is H. According to quantum theory of light, it states that the energy photon emitted or absorbed by a substance is proportional to the frequency of light. So, according to quantum theory of light, we found out that energy is equals to hf. Wow. So this H is called your Planck constant. So if we want to get the dimension, we simply make H the subject formula. And if we do that, we have H is equals to what? E over what? F. So this formula can help us determine Planck constant. Now, remember, H is equals to, watch this, E signifies what? Energy, okay? This E is your what? Energy of a photon. So energy is always force times distance, then over what? Frequency. Force will give us mass times acceleration, then times distance over what? Over frequency. So how do we get the dimension for Planck constant? Planck constant is equals to mass is what? Kilogram, okay? Acceleration is meter per second square. Distance is what? Meter. Frequency is per word, per second. So let's break it further. We have Planck constant equals to, this is kilogram, okay? Meter times meter will give us meter square. Then this is what? Seconds raised to the power of -2 all over what? Seconds raised to the power of -1. So don't forget that we have to combine this with the law of what? Indices. So if we do that, we have to pick one of the ends and combine the power so that we have kilogram meter squared seconds raised to the power of -2 plus 1. Wow. So that Planck constant becomes kilogram meter squared seconds raised to the power of -1. So this is your Planck constant. Remember I made a video last time as regarding dimension for physical quantities. Kilogram has a dimension which is equals to what? M. Yes. Meter has a dimension which is L. So you have L what? Square. Wow. Then seconds has a dimension which is what? T. So you have T raised to the power of -1. This is the dimension for Planck constant. But how do we know the quantity in the option that has the same dimension as your word? Planck constant. Okay? No, I think this option you have angular momentum. Yeah, option B is not momentum, it is angular momentum. So I guess it is option B. Why? Because angular momentum and Planck constant, they have the same dimension. Let me show you. What is the formula for angular momentum? Let's begin with that. Angular momentum. Angular momentum is equals to moment of inertia times frequency. Yeah. Angular momentum is moment of inertia times frequency. What is moment of inertia? It is m arrow square times what? F. Let's quickly break it down. Mass is what? Kilogram. Okay. This is arrow, which means distance. So you have meter square. This means what? -1. Wow. Let's see something. We are going to get the dimension of m, L square T -1. So it should be noted today that Planck constant has the same dimension as what? Angular momentum. So the answer is not power. The answer is angular word momentum because they have the same word dimension. Let's quickly take other questions for today. Now, let's take question number 5. According to question number 5, What is the average velocity if the velocity of a particle is given as what? 4t minus 3t squared at t equals 0 seconds and t equals 2 seconds. What is the average velocity? Now, you must understand something very crucial here, that if your time is equal to 0, the velocity that you are going to get is called the initial velocity. But when your time increases, the velocity you are going to get is called final velocity. So what do we have to do? In this particular question, you do not need to differentiate. It is not instantaneous motion. If they had told us to calculate for the acceleration, it should have been a different thing. This is the velocity, and you are still told to calculate for the average velocity. So you are not differentiating in this question. So what do we have to do? Very easy. Now, if your velocity is equals to 4t minus 3t squared, what do we do? The first time is equals to 0 seconds. So the velocity that we get from time equals 0 is called initial velocity. So our initial velocity, which is denoted as u, is equals to, whenever we see time, we put 0. So you have 4 bracket 0 minus t bracket what? 0 squared. All of this will give us what? 0. Okay? Now, at t equals to 2 seconds, our velocity becomes the final velocity. So we can say that our final velocity, which is v, is equals to 4 bracket 2 minus 3 bracket what? 2 squared. So 4 times 2 is 8 minus 3 bracket what? 4. So what do we have now? We have final velocity equals to 8 minus 3 times 4 is what? 12. That will give us minus 4 meters per what? Per second. So this is our final velocity. Now, if we are looking for the average velocity, what do we have to do to get average velocity? Our velocity will be initial velocity plus final velocity over 2. So initial velocity is what? 0. So you have 0 plus minus 4 over 2. That will give us minus 4 over 2, and you have minus 2 meters per word per second. So the answer is not A, it is not B, the answer is what? C. Now let's take other questions for today. Let's take question number 6. According to question 6, if the angle of incidence is 25 degree, like 25 degree, okay, during total internal reflection, and the critical angle is theta, which of the following is correct? Now the question is this: what is critical angle? What is critical angle? That's question number 1. Question number 2, what is total internal reflection? Do you understand? What is critical angle and what is total internal reflection? Now get your book and your pen, write this down. Now, critical angle is the angle of incidence in the denser medium. Okay, when the angle of reflection in the less dense medium is what? 90 degrees. What do I mean? If I have a semicircular glass like this, watch this carefully. Now, and I have a line here which is called the normal. Okay, now let's assume this is our incident ray. Now, if this is incident ray, this angle becomes the angle of incident. Now, because this is a glass, what we are bound to see is what? Refraction. Why? Refraction means the change in speed, change in direction, and change in the wavelength of a wave when it moves from one medium to another of different densities. This is glass, and this is what? This is air. Now, in the normal sense of view, the ray is supposed to be refracted away from the normal. This is your normal. Now, this is called the angle of what? Refraction. So, critical angle is the angle of incidence in the denser medium when the angle of refraction in the less dense medium is what? 90 degree. Let me explain further. Now, by the time you increase this angle, maybe you increase it to this place now. Incident angle 2. This is incident ray 1. This ray will further increase, okay? It will get to a point where you increase it to that this refracted ray will now be in this place like this. To now make an angle of 90 degree. When you make an angle of 90 degree, then the angle of incidence will be called the critical angle. So the critical angle is the angle of incidence when the angle of refraction is what? 90 degree. So if you further increase this angle, if you increase it, what you will observe is that this refracted ray will become the reflected ray. So now be reflected inside. This is what we call total internal reflection. So we first of all have critical angle before total internal reflection. It means that when the refracted ray is 90 degree, you have critical angle. But by the time the refracted ray go into the glass and becomes the reflected ray, you have total internal reflection. But before total internal reflection will occur, the angle of incidence must be greater than its critical angle, that you must further increase it for this ray to be what? Reflected. So let's view the question again. If the angle of incidence is what? 25 degree during total internal what? Reflection, and the critical angle is what? Theta. Which of the following is what? Correct. Don't forget that 25 degree must always be greater than the word critical angle for total internal reflection to occur. Why? Because if the angle, when we have critical angle, we have refracted angle as 90 degree. That's the angle of refraction. But you have to further increase it to get total internal reflection. So if we assume that if the angle of incidence is 25 degree and during total internal reflection and the critical angle is this, what does that mean? It means that 25 degree must be greater than what? Theta. Yes. So theta must be less than this because the angle needs to be greater than the critical angle in order to exhibit total internal what? Reflection. So let's see the question. So it should be noted that angle of incidence must be greater than the critical angle. Take note of that. For total internal reflection to occur, it must be noted. So according to them, we said the angle of incidence is 25 degree, okay, and the critical angle is theta. But this angle is the angle in total internal reflection, meaning it's greater than the critical angle. So option A say theta is less than 25. Okay, option A say theta is greater than 25. No. The angle of incidence must be greater than the critical angle. Okay? Theta is less than 25. Correct. Which means 25 degree is greater than what? Theta. So the answer is equals to what? B. Now, we have 3 more questions to go for today. Question number 7. In a bridge rectifier, the number of diodes required is 4 for a bridge rectifier. Okay, so note it down, it must be noted. But for a full wave rectification, we need 2 diodes. So if the question had said that for a full wave rectification, the number of diodes required should have been 2. But in a bridge rectifier, the number of diodes required is what? 4. So the answer is what? Is D. Now let's take the next question. Question 8. If 2 capacitors of 40 microfarad and 20 microfarad in parallel are connected to a 12 volt, calculate the what? The capacitance and the voltage across the word capacitor. Wow. What do we have to do? Very easy. Let's solve it this way. Okay? Now, your total capacitance, that's C total, because it is connected in parallel, we have 40 plus 20, and that will give us 60 micron farad. This is the total capacitance of the word capacitor. The voltage, which also means the total voltage, is equals to what? 12 volt. Now, the question says that we should calculate what? The total capacitance and the voltage across each capacitor. Now don't forget that if the capacitors are connected in parallel, okay, in parallel, the voltage remains the same. The voltage remains the same. It must be noted. The voltage remains the same. But in series, the current and charge, current and the charge remains the same. So it must be noted. Okay, for further information, go and check my previous videos on capacitance and capacitor, as well as the video involving the combination of capacitors in series and in parallel. So according to this question, the answer is what? Total capacitance is 60 microfarad, and the voltage across each capacitor is what? 12 volts. So we do not need to solve because the voltage remains the same. Thank you. Now, we have two more questions before we call it a day. Now, we have come to the end of today's video lesson. We are going to take this as your assignment. Look at question number 1. Number 9, it is from conversion of galvanometer to voltmeter. And the question number 10 has to do with, they say, what is the shape of the graph of pressure against volume at constant temperature? That should be referring to Boyle's law, okay? Boyle's law. So Boyle's law, the graph of Boyle's law is best described as what? Is it parabola, hyperbola, straight line, or circular? I'm leaving this question for you. Send me your answer in the comment section. Now this one is a conversion of galvanometer to voltmeter, and then you have hints to the formula. This formula will guide you. Thank you very much. If today is your first time for coming across my YouTube channel, please do well to subscribe to this channel and on your notification bell so that whenever we come online again, you'll get notified. Thank you very much. I'll see you in my next video.